So let's get right into it. We're told all the time that electric cars are the future. Clean, green, planet-saving machines. But what if that shiny new EV has a bit of a dirty secret?
I mean, you've seen the ads, right? You've heard the slogans. 100% electric, zero emissions. It sounds so simple, so perfect for our very complicated world. But is it really that simple? Can the answer to one of our biggest environmental problems actually fit on a bumper sticker? Let's dig in and see what's actually going on. See, the story of an EV's real environmental impact, it doesn't start when you drive it off the lot. It starts way before that, back in the factory. And as we're about to see, it's kind of born with a flaw. Get this, just making a typical electric vehicle can pump out a staggering 40% more emissions than building a regular old gasoline car. That means before it's driven a single mile, it's already deep in a carbon hole. There's a term for this. Experts call it the carbon dioxide backpack. It's this huge carbon debt that an electric car is carrying the second it rolls off the assembly line. And almost all of that debt comes from just one thing, that giant lithium-ion battery. And when you look at the numbers side by side, it really hits home. An EV can leave the factory carrying a carbon debt of up to 12 metric tons. That's nearly double a gas car. And the reason? That battery. It needs 6 times more critical minerals. And how we get those minerals? Well, that's where the clean image really starts to get messy. So, let's take a quick trip to the Atacama Desert in Chile. It's one of the driest places on Earth. Now, to get just 1 ton of lithium for your car's battery, mining companies have to pump up and evaporate over 500,000 liters of precious groundwater. This absolutely devastates fragile ecosystems and threatens the local communities that depend on that water. And hey, it's not just a lithium problem. Let's look at nickel, another key ingredient. In places like Cabana Island in Indonesia, the impact is so bad that locals report the sea has literally turned red from mining pollution. And this isn't just, a weird color in the water. It's a full-on ecological catastrophe. We're talking tropical rainforests being wiped out, toxic heavy metals poisoning the ocean, killing coral reefs and the fish that people depend on to survive. For communities there, it's threatening their entire way of life. Okay, so the manufacturing part is messy, but once it's actually on the road, it's zero emissions, right? Well, not quite. The pollution just changes shape. So here's where it gets really interesting, because there's this weird trade-off happening. On the one hand, you've got regenerative braking, which is awesome. It uses the motor to slow the car down and drastically cuts down on that nasty toxic brake dust. But, and this is a big but, all those batteries make the car 20 to 40% heavier, and that extra weight just grinds down the tires faster, which means more tiny plastic particles getting into our air and water. And that brings us to maybe the biggest myth of them all. This whole idea that plugging in your car is some kind of clean, guilt-free act. There's this concept called the long tailpipe. Basically, your EV might not have a tailpipe, but the power plant making the electricity sure does. You're not eliminating the emissions, you're just outsourcing them. And this is really the whole ballgame right here. How clean your EV actually is depends completely on where you plug it in. If you're charging it on a grid that's heavy on coal, like in Poland, your emissions reduction compared to a gas car is only about 30%. But if you're in a place like Norway with tons of clean hydropower, that benefit shoots up to over 80%. It is not one size fits all.
Okay, so I know what you're thinking. After the carbon debt, the mining disasters, the long tailpipe, is there any good news? And the answer is, yes, actually there is. This is where the story pivots, and we finally get to the payoff.
This graph right here, it basically tells the entire story in one picture. The EV, that blue line, starts out way worse off because of that big carbon backpack we talked about. The gas car, the black line, starts lower. But as you start driving, the EV is just so much more efficient that its line stays pretty flat, and then, right there, it crosses over. That's the magic moment. It's called the carbon parity point, the exact instant your EV is paid off its debt and is officially the cleaner car. So the big question is, how long does that take? Well, you guessed it, it all comes back to the grid. If you're charging on clean energy, you could break even in as little as 17,000 kilometers, maybe about a year for most people. But on a dirty coal-fired grid with a big old battery, you could be looking at more than 95,000 kilometers.
All right, let's zoom out and put all the pieces together. The reality here is complicated. Yes, EVs start with a serious carbon debt. Yes, the mining for their batteries causes very real, very severe damage. And yes, how clean they are is completely tied to the electrical grid. But, and this is the part that really matters, over the entire lifespan of the car, from the factory to the scrapyard, an EV is still the better choice for the climate. On average, we're talking 50 to 70% lower emissions. So no, they're not perfect, but they are a whole lot better.
So you see, the truth isn't some simple slogan. An EV isn't a perfect, magical solution. It's a bundle of trade-offs. We're solving the huge problem of tailpipe pollution, but we're creating new, serious challenges with mining and manufacturing. Which leaves us with one final big question. Are we actually saving the planet, or are we just shifting the environmental bill to a different place and a different part of our ecosystem?